Evaluate the integral of 1 over the square root of a quadratic. When I have the integral of 1 over the square root of a quadratic, I want to try to make it look like this. I want to make it look like the square root of a quadratic and see if I can pull this off. If I can do that, right, I can think inverse sine thoughts because the inverse sine comes from this. So this is what I need to do. Okay, let's get rid of that. I'm going to pull out just the stuff underneath the square root. Okay, so negative x squared minus 2x plus 8. Okay, and I'm going to think completing the square thoughts. Okay, so let's do this. Let's pull out a negative. So that leaves me with x squared plus 2x. Let's leave some space right here and keep that plus 8 out off to the side. Okay, now completing the square, this is going to be tricky, so kind of follow me here. I'm only inside the parentheses right now. If I were to take half of this, which is 1, square it, which is 1, and add 1 to that, I'm good. Now me adding 1 to this is the same as minus 1 in this whole chunk right here. If I were to subtract 1 from an expression, the only way to balance it out is if I add 1 over here. But this is good news, because what this gives me is negative. That becomes x plus 1 squared plus 9. Now rearranging it like that, right, because it's the same thing, and then turning u into 3, I now have what I showed you I needed from before. Okay, so I'm going to rewrite this guy up here as that, so I now have the integral of 1 over the square root of 3 squared minus x plus 1 squared dx. Using u substitution, I will let u equal x plus 1, so du dx is going to equal 1, and du is going to equal dx. So now I have the integral of 1 over 3 squared minus u squared du. Okay, that becomes the inverse sine of u over 3 plus that arbitrary c. Replacing u, I now end up with the inverse sine of, x plus 1 over 3 plus c. So definitely not an easy problem. Definitely not an easy problem. I got a little stumbled up here when I was trying to remember what I was supposed to do because inverse trig functions are not my favorite. But we end up with this. So yeah, not fun.